In this video, we'll be solving absolute value equations, but this time we'll be looking at things that are slightly more complex. So for example, we might have something like this, but now instead of the absolute value being alone, there may be something around it. And we're going to talk about what we do and how we go about solving this equation if this occurs. So as I mentioned on the previous slide, we'll be looking at what happens when the absolute value is not alone on one side of the equation. And before we start solving things here, the one thing we need to know is that these absolute value bars, they act like prison bars and nothing can break in or out. So we already talked about how we can't add 3 to each side and break that 3 out until we split the equation into 2 mini equations. The other thing we have to know is that while it's going to be very tempting to distribute this 2, because of the way that absolute value bars work, you cannot distribute this 2 inside. So we're going to talk about what steps we have to take if we can't distribute this 2, but we have to be able to split this absolute value somehow to get the 3 out. So we're obviously a little bit stuck if we can't distribute in and we can't get that 3 out now as is. So we're going to talk about steps that we can take to help us solve this. So here are the 3 main steps that we're going to follow for every single absolute value function that we solve, whether it's an easy one or it's a more complex one. So the first step here, it says to solve for the absolute value alone on one side of the equation. So what we're going to do is we're going to take this piece that is inside the absolute value and we're going to get the absolute value by itself. So right now we're kind of going to treat the absolute value like a variable and we're going to get that absolute value entirely alone. So I'm going to start by subtracting the 4 from each side. So we have 2 absolute value, x minus 3 is equal to 10 minus 4 is 6. And then still remember, our goal is to get the absolute value alone. So now I'm going to divide each side by 2. So notice that I was able to get my absolute value by itself. So here we have the absolute value of x minus 3 is equal to 3. Notice that I was able to get the absolute value by itself without distributing anything in. So that's always going to be our first step, to solve for the absolute value alone on one side of the equation. Now from here, it's the same process as before. What's inside the absolute value can equal 2 different values. So we talked about how this inside piece here, because of the way that the absolute value works, the inside can equal 3 or negative 3, because absolute value is going to turn it into a positive value. So we're going to set what is inside the absolute value equal to the 2 possible numbers that it could possibly equal. And that is how we break down, essentially, those walls there. It's how we break down the absolute value walls. So we're going to break down this wall by setting this inside piece of x minus 3 equal to the first value, which is 3. X minus 3 can equal 3. And if it does, that would result in an absolute value that is equal to 3. And then on the other side of it, this inside piece, so we can break down the second wall by taking x minus 3 and setting it equal to negative 3. So here, now all we need to do is solve these 2 little mini equations, and we will find 2 values for x. So we are going to add 3 to each side, so we get x is equal to 6, and if we kind of visualize this answer, 6 minus 3 is 3. The absolute value of 3 is, as you can see, 3. Then from here, we're going to add 3 to each side as well, So we get x equals 0. And again, we can kind of test it out and visualize it. 0 minus 3 is negative 3, and the absolute value of negative 3 is 3. So we have found our two values that make this original equation true. So let's go ahead and give this next one a try. Now remember, because the absolute value is mixed into an equation, we need to get the absolute value alone first. So our first step, step 1, is to get the absolute value alone, because we can't break anything in and we can't break anything out. So we're going to start here by adding 6 to each side. So I have negative 3 absolute value, 2x plus 4 is equal to 27 plus 6 is 33. And then from here, I still need to get the absolute value alone. I cannot distribute inside. So we divide each side by a negative 3. And we have the absolute value of 2x plus 4. And that is equal to a negative 11. So now that I have my absolute value completely by itself, I can start thinking about this inside piece here and brainstorming what values that inside piece could equal in order to get an absolute value of negative 11. Now, I know absolute value represents distance, and this is saying that we have a distance, or an absolute value, distance from 0, of negative 11 units. And now that I have my absolute value alone, I can see that that's something that is not possible, right? So if you get your absolute value alone, you have it all by itself, and you can see that the absolute value function equals a negative number. We know that we can't have something that is a negative distance from 0. A negative distance from 0 is not something that logically exists. So here, because you have an absolute value all by itself, so notice absolute value that is alone, and that absolute value alone equals a negative number, that is when you can stop and say that there is no solution. So let's take a look at another different but slightly similar example. So here we can see that we need to get our absolute value by itself. We know that that is our first step, because we can't break into that absolute value and we can't break anything out until we get it alone. So from here, we're going to start by subtracting 6 in order to get that absolute value alone. So here we have 3, absolute value, 2x minus 4 is equal to 36 minus 6 is 30. Then from here, I notice I cannot distribute in because I cannot break into the prison there. So I still have to get my absolute value alone. So I divide by 3 on each side. So I end up with absolute value of 2x minus 4. And that is equal to 30 divided by 3, which is 10. So now from here, I can start to think about what will the inside of this absolute value have to equal in order to produce a distance from 0 of 10. And there are two possible values that this inside piece could equal. This inside piece could equal 10, or this inside piece could equal negative 10, because those are the only two numbers that, when they are put inside of an absolute value, have a distance from 0 of exactly 10 units. So in order to break down these prison walls, I'm going to set this inside piece of 2x minus 4 equal to 10, and I'm going to set it equal to a negative 10. And then from here, all I have to do is solve my two mini equations. So I'm going to add 4 to each side. So we have 2x is equal to 14, divide by 2. And I find that one option is x is equal to 7. Then from here, same deal, but slightly different number. So we add 4 to each side. So I have 2x is equal to negative 6. I divide each side by 2, and I have x is equal to a negative 3. So let's take a look at this final example. So I know that for some of you, it's going to be really tempting to pause and say, oh, there's a negative on the right-hand side of that equals, and this has to be a no solution case. Unfortunately, we are not able to make that call until we get this inside piece, until we get the absolute value all by itself. So remember, in order to make a no solution call, you have to get the absolute value entirely alone, take a look at the equation, and then make that judgment call. So here, to get our absolute value alone, we start by dividing by 3, or negative 3, excuse me, on each side. So as we do that, we end up with absolute value of 2x minus 6, and that's equal to a negative 15 divided by negative 3, which is a positive 5. So if you take a look at what happened here, you'll notice that as we solve to get the absolute value alone, it is now equal to a positive, which tells me that this is in fact possible. So that is why we have to be careful not to make a no solution call too early, because this one has a solution. When we get the absolute value alone, it equals a positive number. And so what we can start to do now is we can start to brainstorm what the inside piece here is going to equal. So the piece inside of the absolute value could equal 2 possible numbers. This inside piece could equal 5, or it could equal negative 5, because those are the 2 numbers that, when they're inside of an absolute value, result in a distance from 0 of 5. So here we're going to take 2x minus 6 and set that equal to positive 5. Then I'll break down the second wall by taking 2x minus 6 and setting that equal to a negative 5. And then from here, we just need to solve each mini equation. So I start by adding 6 to each side. So I have 2x is equal to 11. And then from here, I need to divide each side by 2. So I have x is equal to, because 11 doesn't divide nicely by 2, I'm just going to leave my answer as 11 over 2, because that is the most exact answer I have. Then on the other side over here, I'm going to add 6 to each side. So I end up with 2x is equal to 1. Divide both sides by 2. And then I'm going to leave my answer as x is equal to 1 over 2, because 1 is in the top and 2 is in the bottom. And I'm just going to leave my answer as a fraction, since 1 doesn't divide by 2 nicely. So these are my 2 answers for x, where if I put them back into this original equation, they will make the original equation true.